All right, let's take a whack at this one. This is from 8.5, I believe. 8.5. Let me double check that. 8.5. Yep, it's from 8.5. All right. Here we go. 8.5. All right, where's my pen? Can't find it. There it is. All right. So it says find extrema and points of inflection. So I need first derivative, second derivative. So I know how to take derivatives because I've been doing this for a while. This is a quotient rule. So I'm going to go the bottom times derivative of the top minus the top times derivative of the bottom. Derivative of ln of x is going to be 1 over x all over ln x squared. Y prime therefore equals ln of x minus 1 all over ln of x, the whole thing squared. How do I find where I have maximums or minimums or extrema? I have to set the derivative of the top and bottom equal to 0. The bottom can't be 0 because you can't raise something to a power and turn it e to something and turn it into 0, so that's never going to happen. The top, though, is interesting because the top I could set 0 equals to ln of x minus 1. 1 equals ln of x. Swing the e across. I get e to the 1 equals x, or x equals e. So at e, now that isn't necessarily an extreme. I have to check to see if its sign changes, right? So e to infinity. So I'm going to check a number between what did I just do here? Negative infinity and e. Now I can't check a negative number because log natural of negative number is ridiculous. So I got to check something between 0 and e. And e is about 2.7, so I'm going to check 1. Log natural of 1 is 0. 0 minus 1 is negative. The bottom's got to be positive, so it's going to be decreasing. Pick a number bigger than 1, bigger than e, 5 billion. ln of 5 billion minus 1 is going to be a positive number. The bottom's got to be positive. It's squared. So we're increasing. So we go from decreasing to increasing. So there's a local minimum there. So they're at x equals e. There is an extrema. All right, now I'm going to go ahead and with the first derivative. Now I'm going to find concavity or points of inflection. So I take a second derivative, y double prime. It's going to give me a big old mess up on top. I get ln of x, that whole thing squared, times the derivative of the top, which is going to just be 1 over x. The 1 goes away right here. This 1 goes away. Minus the top times the derivative of the bottom. The bottom's going to be, take derivative of the outside if the inside was an x. So I'm going to do a chain rule. ln of x times derivative of the inside, which is 1 over x, all over ln of x to the 4th. Isn't that fun? Okay, I'm going to note that I have an ln x here, so I can turn that into a positive number. I can, turn that into 1. I can get rid of it here and turn this into a 3. Actually, that doesn't do much good, but I might as well go ahead and do it. I've got an x in this expression, x in this expression, so I'm going to go ahead and drop those down to here. And I get y double, oops, that's not the right place, y double prime equals ln of x minus 2 ln of x minus 1 all over x ln of x to the 3rd power. Again, can't pick a negative x, so that's not even a part of the realm I'm interested in. Therefore, I can't make it 0 either, by the way. So therefore, from 0 to I don't know where. So I got to set the top equal to 0. So simplifying the top a little bit, I'm going to get negative ln of x minus 1 over x ln of x to the 3rd power. Again, ln of x can't be negative or 0, so therefore 0 is our boundary. Making x equal 0 makes the bottom undefined, but we already said we can't be there, so that's already the edge of my graph. So now I'm going to set the top equals 0, negative ln of x minus 1 equals 0, negative ln of x equals 1, ln of x equals negative 1. To what power do you raise e to make negative 1? I can't, so there's a no. So there are no points of inflection. Ta-da! Okay, so that's the first one of this set of fun problems. So this is 39 on 8.6. It says solve differential equation, which means I want to get the original equation. This is derivative. What is the original equation? So I'm simply going to go, integrate both sides. That might be tricky. Yep, that's going to be tricky. So I'm going to integrate the left side. I get s. On the right-hand side, I'm going to get sine. I'm going to go ahead and make this sine of 2 theta over cosine of 2 theta, because I don't know how else I'm going to do this. I'm going to set u equal to the bottom. U equals cosine 2 theta, because I think that's what's making my life the ugliest. Du, therefore, is equal to 2 negative sine of 2 theta. Again, take the derivative of the outside, which is negative sine, to the inside, which is 2. So I end up with this mess. Anyway, I can make the top look like that. Certainly, I just need a negative 2. So I'm going to go negative 1/2 the integral of 1 over cosine of 2 theta, negative 2 sine 2 theta d theta. Recognizing what I have here, I'm now going to set this equal to, I get negative 1/2 integral of 1 over u du, which is going to be equal to negative 1/2 ln, absolute value of u, plus c, which gives me negative 1/2 ln of absolute value of cosine 2 theta plus c equals s. All right, so they tell me my point is 0, 2. Okay, so when I plug in an angle of 0, I should get 2. So I'm going to put a 2 in where the s is, negative 1/2 ln cosine of 2 times 0 is just 0 plus c. Cosine of 0 is 1. ln of 1 is 0, so this whole thing cancels out, and I get c equals, or 0 plus c equals 2, which is same as 2 equals c. So my final equation would be s equals negative 1/2 ln absolute value of cosine 2 theta plus 2. All right, so that's my differential equation for that problem. Pausing there, get ready for the next problem. Here we go. All right, Extrema is in points of inflection again. So we need to take the first and second derivative. Here we go. 65. So I got to find the derivative. So this is not really a division problem. So what I'm going to do is I'm just going to go ahead and note that this is the same thing as, because I only got 1, 2 on the bottom. I can just write this as 1/2 e to the x plus 1/2 e to the negative x. Derivative of that would therefore be equal to 1/2 e to the x, because 1/2 doesn't do anything. Derivative of e to the x is e to the x, plus, and then 1/2 e to the negative x, but that's not an x, I have to tack on a negative 1. So then, so the first derivative would be that. (1/2 e to the x minus 1/2 e to the negative x). The second derivative would be f of x, f prime of x we just said was this. So if I want to find the second derivative, I'm going to take the derivative again. So that would be f double prime of x is equal to, hey, the first thing doesn't change again. The second thing becomes negative 1/2 e to the negative x times negative 1. And so it goes back to the original equation. 1/2 e to the x plus 1/2 e to the negative x. All right, so where is this thing equal to 0? I set the whole thing equal to 0. I get 1/2 e to the x minus 1/2 e to the negative x. A couple ways I could approach this. I'm going to note that this is an e to the negative x, so I'm going to put it on the bottom. I'm going to move it to the other side. So I get 1 over 2 e to the x equals 1 over 2 e to the x on top. The 1/2's canceled out, and I get, where does 1 I get 1 over e to the x equals e to the x. I could put it back on top. That would solve my problem. But I'm going to go ahead and move it over to the other side. Move to the other side, e to the x times e to the x. The base is the same, so I add the exponents, and it becomes e to the 2x. Where does this happen? I could ln both sides, or I could recognize what power do you raise e to make it 1. 0, right? So 2x equals 0 when x is equal to 0. So I'm going to check my point to see if it actually is a extrema. So negative infinity to 0 and 0 to infinity. Go back to my first derivative. If I set a number like 4 in there, this is a really powerful number. Okay, it's a really powerful number. This ends up being a negative 1 over number, right? So this ends up being e to the 4th on the bottom. Actually, you know what? Let's just plug 1 in. Okay, so I'm going to plug 1 in here. Okay, so I get 1 over e to the 1 minus 1/2, sorry, 1 over e to the 1, right? Obviously, this is bigger than this, so it's going to end up being positive. Now, if I put a negative power up here, it flips, right? Because if I put a negative 1 in here, this becomes 1/2 e to the negative 1 minus 1/2 e to the 1. So this would go on the bottom. If this goes on the bottom, it's smaller, so this becomes negative. So in fact, at x equals 0, I have a maximum, a local maximum. All right, so now I got to go back to this function here. Yep, I can't find a pen. Here it is. Okay, got to find where this is concave up or concave down. I look at it and go, set the whole thing equal to 0 equals 1/2 e to the x plus 1/2 e to the negative x. I move it over. I get negative 1/2 e to the negative x equals 1/2 e to the x. Cancel out my 1/2. So I get negative e to the negative x equals e to the x. Is there any way to raise this power to make a negative number, which is what we're trying to do? I can raise nothing to a power and make it there. Or I could ln both sides. If I ln both sides, I'm ln'ing a negative number. That means I can't do it. So therefore, there are no points of inflection. All right, pausing it. See if I can get the last one in before my time expires. All right, more of the same. First derivative, second derivative. So I get two things multiplied together. So I use a product rule. F prime of x equals 2x e to the negative x plus x squared e to the negative x times negative 1. So f prime of x would be equal to 2x, since it's e to the negative x, I'm going to put on the bottom, make my life a little bit better, minus x squared over e to the x. Then logically I could rewrite this as 2x minus x squared over e to the x is my first derivative. And then setting it equal to 0, I would set the top and bottom to 0. The bottom can't be 0 because I can't raise something to power to make it 0. So the top is 2x minus x squared. I would get x 2 minus x factoring, and I get the fact that x has to be 0 and 2. So now I'm going to check from negative infinity to 0, from 0 to 2, and from 2 to infinity to find my points of inflection. I'm just going to plug a number in. If it's positive, negative, it switches. It's a extrema. Okay, so then taking the second derivative. Again, I'm running out of time, so I'm just going to. Let's might as well do it. Hold on, I'll do it. We'll make a second video. That'll be good. All right, so plug in a negative 1. The bottom can't be negative. We just said that 3 or 4 times. So therefore, if I put a negative 1 in here, I get negative 2 minus 1. So that becomes negative. So that's decreasing. I put in a number like 1, and I get increasing because I get 2 minus 1. I put in a million. A million squared is bigger than 2 times a million, so therefore I get decreasing again. So at x equals 0 and x equals 2, I have an extrema. All right, pausing. I got to pause this and start on the next video.